Hello friends, in this video we are going to take the simplest topic of this chapter called combinatorics, and the name of the topic is the sum rule, and we are going to take the concept of the sum rule, and in the same video we will also try to see what are the basic applications of this, because this is the simplest of all the counting rules. Imagine that you have two floors in a mall, and all of these two floors contains two shops. So there are two shops, one on each floor. So let's say the shop number is shop number 1 and shop number 2, and both of these shops give different kinds of garments. So let's say S1 contains only jeans, S2 only t-shirts. Fine. So both of these shops offer the different garments, and S1 contains only jeans, S2 contains only t-shirts, and let's say there are capital J number of jeans and there are capital T number of t-shirts. So J jeans and T number of t-shirts. So our choice is that given the budget, we can buy only one garment. So only one garment in totality. That means it could be either a jeans or it could be a t-shirt. But we cannot buy both, because in our budget, let's say we can buy only one of these. So only one garment. So now we have the choice set as jeans number 1, jeans number 2 up to jeans number capital J, and we have the second choice set, t-shirt number 1, t-shirt number 2, and we have capital T number t-shirt. So because we can now select only one of the garment, only one garment again. So the question is, how many ways can you do the shopping? So the number of ways of shopping. So now you can readily guess that the number of ways you can shop, the answer is capital J plus capital T. This is the answer. You can readily guess it. Why? Because you have observed that we can buy only one of the garment in totality. So it could be either jeans or it could be either t-shirt, and we have to buy only one. So this implies that we have an exclusion in the choice. It could be either a choice from the set choice 1 C1, or it could be a choice from the set choice set C2, but it cannot be both at the same time. So there is something called as an exclusion, and that exclusion directly tells you why we are trying to use the addition here. So rather than trying to remember that when to use addition or when to use multiplication, here is the guideline. So this exclusion, try to watch for exclusion. So once you observe that this exclusion is observed, then immediately you should come to know that there is an exclusion between the two choice sets C1 and C2. So now you add the sizes of their choice sets, because the exclusion tells you it could be only this or that, but never both. So there is no point of having intersection. This is the counting principle called addition. The addition principle, as the name suggests, or the addition rule or sum rule. So the rule says if we have the choice set C1, you have the choice set C2, then the number of ways to select only one from C1 or C2 is equal to the size of the set choice set 1 plus size of the choice set 2. So your choice sets could be anything. Your choice set could be, set C1 could be the set of t-shirts, C2 at the same time a set of jeans, or set C1 could be the set of boys, set C2 could be the set of girls, C1 could be the set of buildings, set C2 could be the set of areas. It could be anything. So this overall principle is as simplest as possible, which will be repeatedly used. So we'll generalize it to the generalized sum rule, which says that if you have choice set 1, choice set 2, choice set 3, up to, let's say, n choice sets. So there are n choice sets you have. So this really means that you have n choice sets available. So the number of ways of selecting only one from, you could readily guess now, the wording should be the number of ways of selecting only one from C1 or C2 or C3 up to Cn is equal to the size of the choice set 1 plus size of the choice set 2. You add all the sizes, which could be readily summarized as the cumulative sizes of all the sets. So this is a generalized sum rule, and why this generalized sum rule is true is same like the way you add three numbers. There is no rule to add three numbers, but you could add three numbers by repeatedly adding two numbers. So first you add two numbers, then you add the result to the third number. So you invoke the binary additions again and again. So the same way, the generalized sum rule also suggests you the same thing, that you have the number of choices available for the set 1 or set 2 up to set n. Then first you resolve the problem of selecting one from set 1 or set 2. You know that if it is neither set 1 nor set 2, then it could be from set 3. So set 1 and set 2 together, they give you mod C1 plus mod C2 choices. So the of properties or the conditions, we should be interested more in when the sum rule is to be applied. So now, rather than writing the sum rule again and again, we know that we are talking about the sum rule. What should be observed in any particular question? Which condition should be observed? There should be exclusion in the choices. And second, exclusion in the choices. And the second, the choice set should be mutually disjoint. Choices should be mutually disjoint. That means the choices sets should be mutually disjoint. So now we will take these properties one by one, and we will see what do they actually mean and why only these two properties or these two conditions imply that the sum rule should be used. And only when you satisfy both of these properties, then and only then you should go for the application of the sum rule. So we'll go with the first one, called the exclusion in the choice sets. So first, which is rather the simple one, the wording is called or. Only this or that. These imply that, let's say you have the set of genes. There were, let's say, a number of genes, and you have b number of t-shirts. So continuously we'll keep on using the different variables for indices and the limits of the indices, so that we should not be confused about invoking only one particular name or one particular symbol for a particular purpose. So its exclusion says that you have to buy either jeans, either or t-shirt, and you have to pick up entirely. That means now you cannot break down the choice set, you cannot break down the garment. So this really means that now in the first set you have A, in the second set you have B. So totally you have A plus B choices. Now why we cared about writing down A plus B is because you already know the size of the choice set J. Okay, this is really the choice set C1, and we also know the size of the choice set T, which is really the choice set C2. And we are not going to go into the question of resolving this question of how to find the size of this first choice set. How do you know that there are A number of genes? How do you know that there are B number of t-shirts. We really know that we can actually count it via setting up one-to-one correspondence. So reliving about that question, we know that the exclusion of choices really means only the use of the words called either or, only this or that, and that too in entirely. So the second is mutually disjoint choices or mutually disjoint choice sets. So imagine the situation that you have two floors in a mall and there is shop 1 which contains G1 sets of garments, and there is a shop 2 on the second floor which contains G2 sets of garments. Now this time I am saying G1 sets of garments and G2 set of garments. So there is small G11 which is the first garment of the first shop, G12 this is the second garment of the first shop, G13 is the third garment of the first shop, let's say up to G1A, meaning this is the eighth garment. So the size of the garments is equal to A, and G21 is the first garment of shop 2, G22 second garment of shop 3, G23 up to G2B. So the number of garments in the second shop is, let's say, B. So why we bother about mentioning garments rather than jeans and t-shirt? Because this time the garments could be shirts, trousers, jeans, it could be anything at all. And so both of these shops may contain any number of garments, let's say precisely A number of garments in the first and B number of garments in the second. What do you mean by mutually disjoint choice sets is, let's say there is some garment, let's say G1I, that means there is an ith garment in the first shop which is same as G2J, that means there is a jth garment in the second shop. So let's say the fourth garment is jeans from a particular brand in the second shop, and the first garment in the first shop is, let's say, the same jeans. So that means you have the same jeans now here and there. So because you have the same jeans which is copied on the first shop and the second shop, and imagine that there are prices are also same, so that means everything about garment is same. So everything about G1I matches with. So that is the notion of the exact equality, that these two garments are exactly same in all respects. Their prices are same, their dimensions are same, their utility is same, everything is same. So in that respect, one garment is copied as far as you are considered. So altogether, how many really different garments for you are there? So you can readily observe that you already counted G1I as a part of A objects in the first shop. You also again counted the same garment as a part of the second shop which contained the B number of objects, that means the B number of garments. So that means as far as you are considered, the same garment is copied here and there, so you don't really count it separate, you count it to be the same garment. So you will say that there are altogether A plus B minus 1 garments, because you know that that same jeans was copied in the first shop and it was present in the second shop also. So this is with respect to you, it has nothing to do with the shops, it is all with respect to your perspective. So there are really A plus B minus 1 choices. Why? Because the two shops are not disjoint, because G1 intersection G2 is not empty. So this is exactly what is happening. The number of choices are reducing if the same choice is available in as a part of the first shop and as a part of the second choice set also. This we don't want. This means G1 intersection G2 must be equal to empty. So if G1 intersection G2 is equal to empty, in that case we can say that the number of choices is equal to the addition of both the choice sets. So you can do the perfect addition and you can say that the answer stops at perfect addition only when the intersection is empty. So now generalizing, you have, let's say, G1, G2, G3. So what you want for these sets to be mutually disjoint is G1 intersection G2 should be empty. There should not be anything common between these first two shops as far as shops are considered. Now it doesn't stop here. There should not be anything common with the second and third shop also. Now even it doesn't stop here. The third condition, similarly saying there should not be anything common between the first and the third. So if there are 3 shops, you should not have anything common between the first 2 shops, the second 2 shops, and the first and the third shop. This is what we call as mutually disjoint choice sets. Thank you so much for watching this video. Stay tuned with Ekeeda and subscribe to the channel Ekeeda.